Alright, so now for the polar form of complex numbers. So complex numbers, as I told you, can be represented as a plus bi, but they can also be represented as r cis, I think that's how you pronounce it, r cis theta. So what this is, it really just is r times cosine theta plus I sine theta. And so we can think of this as just, again, as I always say, we can think of this on the plane as, let's say, for example, we wanted to represent 2i. Okay, this is our imaginary axis, this is our real axis, and you want to represent the number 2i. Well, if this were the polar axis, this angle right here, this would be pi over 2. So when we have pi over 2, sine is 1 and cosine is 0. So this would become, if we had cosine pi over 2 plus I sine pi over 2, this would just become I, right? Because this is 0 plus I times 1. And so we have to multiply by that by the radius, or the magnitude of this number, which is clearly 2. So this would just be 2 times cosine pi over 2 plus I sine pi over 2. And again, I know I always say this, but it really does help thinking about this graphically, because we do have a radius of 2 and our angle is at pi over 2. Okay, now let's do another example. So let's say we had the number square root 3 minus I. Alright, so how do we represent that when we have, let's say, w equals square root 3 minus I? Well, we know this is, square root 3 minus 1i. And so if we were to divide both of these by 2, we would get some commonly seen trig values. So we can say that w is equal to, if you take out a 2, square root 3 over 2 minus 1/2 I. And so what do these numbers look like? Well, we know sine goes with I, right, because it's on the imaginary axis, and cosine goes with the real numbers. So we can say what numbers give us, 3 halves in cosine, which angles, and give us negative 1/2 in sine. And if you were to think about that, a square root 3 over 2, for cosine. I think I said that wrong. That would be about right here. And this is negative pi over 6, so 11 pi over 6. And so we just say that 2 times cosine 11 pi over 6, 11 pi over 6, plus I sine 11 pi over 6. Remember, this is just 2 times square root 3 over 2 minus 1/2 I, right? This will give us square root 3 minus I. So when you don't have a calculator or something, you usually will see just numbers that can be made into common trig values. It is worth mentioning that when you don't have nice numbers, there are also other steps you can take. So, for example, if we have the number, square root 3 minus I, so that means A is the real part is square root 3, and the imaginary part, b of our complex number, is negative 1. So on a graph, if we graph this like I enjoy doing, right here we would have square root 3 as because remember this is the real axis, so this length would be square root 3, and in the imaginary axis it would be minus 1. So we'd have a triangle with this side of negative 1 and this side of square root 3. So if we wanted to find the radius and the angle, because that's really all we need for a complex number in polar form, remember they're just r cis theta. To find the radius, we just do Pythagorean theorem. So a squared plus b squared, which is square root 3 squared, which is 3, plus negative 1 squared, which is 1, which is the square root of 2. So the radius is 2. Oh, sorry, it's the square root of 4. So the radius is 2. And the angle is just yeah, it's just the inverse tangent of, actually maybe I should say it better, like the tangent of the angle is -1, because this is the angle, right, is -1 over square root 3. So this means that the angle is equal to the inverse tangent of -1 over 3, which is at the angle of 11 pi over 6. So that means theta equals 11 pi over 6, over square root of 3, sorry. And so as you can see, this is without simplifying it into convolution trig values. There's also a very easy way to just find the radius and the angle. Some other nice things you can do with complex numbers in polar form is multiply and divide. So first, let's just focus on multiplying. So if you have two complex numbers, and let's say the first one is called C, and it's R cis theta 1, so R1 cis, let's say theta 1. And then our second one is R2 cis theta 2. Well, the product of those two numbers is just going to be R1 times R2, and then it's going to be times cis theta 1 plus theta 2, right? Or you can say that's just equal to R1 times R2, and then cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2. Okay, so that's what we do to multiply. And that's just the general formula, but let me show you an example. So let's say we had two complex numbers. The first one we can call 5 cis 30 degrees. And the second one, let's call, 3 cis 60 degrees. Well, the product of those two numbers is just going to be the product of their radii. So 5 times 3 times cis of theta 1, which is 30 degrees, plus theta 2, which is 60 degrees. So when we expand this out, we get 15 times cis of 90. So cosine of 90 degrees plus I sine 90 degrees. And so this is just 15 times cosine of 90 is just 0, plus sine of 90, which is 1, so plus 1i, and so this is just 15 times I, so the product of these two complex numbers is just 15i. And so if you were to multiply out these complex numbers in their normal, complex form, I guess, in the Argand plane, like a plus bi, you'd also get that the answer was 15i, which let me just show you so we have more practice with complex numbers in general. You can skip this part if you want. So 5 cis, I want more practice converting from polar to the form a plus bi. So 5 cis is 30, that's 5, remember r, times cosine 30 plus I sine 30. So this is 5 times cosine 30 is square root 3 over 2 plus sine 30, which is 1/2, and then I. So this is going to be 5 cis 30, and we could distribute the 5, but we're just going to be multiplying this out anyways, so I don't really see the point. So for the next number we have, this is z, this is w, this is 3 cis 60, right? And so we write that as 3 times cosine 60 plus I sine 60 degrees, which is equal to 3 times cosine 60 is 1/2, plus I sine 60 is square root 3 over 2i. And now when we multiply these numbers, well, the 15, let me write it here and go down a bit. Well, the 5, so it's going to look something like this. 2 plus 1/2 I times 3 times 1/2 plus square root 3 over 2i. So let's just focus on these two first. We can say this is 15 times the product of square root 3 over 2 plus 1/2 I times 1/2 plus square root of 3 over 2i. And when you multiply these out, we get of 3 over 4 plus, this is square root of 3 over 2 times square root of 3 over 2, so 3/4 I plus 1/4 I, and remember I'm just multiplying these two out, and then plus square root 3 over 4 I squared, which is minus square root 3 over 4. So as you can see, these two will cancel out, and we're left with 15 times the sum of these two numbers, which is just I. So our answer does indeed become 15I, which is exactly what we got up there. So you can decide which method you like the best, but you can't argue that this method is certainly useful, and it would be useful to learn how to do it well. So next, let's talk about division. So let's divide. So if you have two complex numbers, z equals r1 cosine theta 1 again, and w equals r2 cosine theta 2 again, when you divide, z over w is just going to equal r1 over r2, and this is exactly like the opposite of multiplication, times cis of theta 1 minus theta 2. And so you could also write that as r1 over r2 times the cosine of theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Alright, so let's do one example of dividing these numbers. Let's say we have 4, the first number is 4 cis 45 degrees, and our next number is 3. I'm not using very big numbers here. 45 degrees. Or let's say instead of 45, let's stick to something that's not in the first quadrant. Let's say, how about why am I agonizing over this so much? It's literally not even a huge deal. Yeah, 135 degrees. Second quadrant. How scandalous. How much of a change. Okay, anyway, so let's divide these numbers. So z over w, this is going to be 4 over 3 times cis of 45 minus 135 degrees. So 45 degrees minus 135 degrees. So this becomes 4/3 cosine of 45 minus 135 is negative 90 degrees plus I sine negative 90 degrees. And so this is just 4/3 times the cosine of negative 90 is going to be 0. So 0 plus I, the sine of negative 90 is negative 1. So negative 1I. So this just becomes 4/3 times negative I. So it's negative 4/3 I as our final answer, dividing. And if you want more practice, I'm not going to do it in the video, but you could convert these into the form a plus bi and just, multiply them the way you would complex numbers in that form to check the work.